Alrighty, so we're going to talk about, in this first lesson of the third part of chapter 7, we're going to just talk about parallelograms, rhombi, rectangle, squares, and their properties before we get into the main part of this chapter 3. So not chapter 3, part 3 of chapter 7, which is actually writing proofs involving parallelogram properties. So when you see this diagram here, I want you to think of a family tree. And I'll tell you why. Everything starts with a parallelogram for the quadrilaterals, four-sided shapes. And notice how from a parallelogram extends two shapes, and then from those two shapes extends another shape. So it's a family tree. So let's first talk about parallelograms. I will abbreviate it like this when you see me write it in class. That's just a set of parallel lines and then the ogram. I don't know. So opposite sides are parallel. So that means you're going to have this. Opposite sides are congruent. So the same measure. I'm going to use my tick marks here. Opposite angles are congruent. So we have this. Opposite angles are supplementary. So this is what that means. Remember that supplementary adds to 180. And consecutive is going to be like next to, not opposite. So for example, this angle plus that angle has to equal 180 degrees. And then our diagonals, we'll get into that more by the way, but our diagonals bisect each other. So bisect, I want you to think of split into two equal parts. So this diagonal splits this diagonal, the other diagonal, into equal parts. And then this diagonal is going to split this one into two equal parts. I should have added another tick mark here. Gets a little messy, sorry. Okay. So that's a parallelogram, right? Really important that you get these properties down because every shape includes these properties now. Let's start by looking at a rhombi. Looking at rhombi, that's plural for rhombus. So I want you to write this. A rhombi has all the properties of a parallelogram plus dot 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 these three properties. So for congruent sides, diagonals are perpendicular. Perpendicular forms 90-degree angle. So like that. And diagonals bisect opposite angles. So for that, splits angles into two equal parts. So that's going to look like this. Let's jump over, look at a rectangle. Now with the rectangle, the same thing applies. It has all of the properties of a parallelogram plus these two. So for right angles, already marked for you. That's nice, think of corners. And then the diagonals are congruent. So what that looks like is this. Okay. Yeah, so the whole length of those diagonals are congruent. All right, so those are our second and third shape, and then from rhombi and rectangle come squares. So squares have all the properties of parallelograms, rectangles, and rhombi. So everything that we just talked about fits into a square. So that means right angles, diagonals are equal, opposite angles are congruent, all the sides are congruent, parallel, opposite sides are parallel, okay? So let's go ahead and move down. I'll give you a minute, maybe write that down. Let's go ahead and move down to actually using these properties. So just a quick refresh. Opposite angles are parallel. I'm going to use my abbreviation, and then I'll spell it out in parentheses here. Opposite sides are congruent. Opposite angles are also congruent. Consecutive angles are supplementary. And that adds to 180. And then diagonals bisect each other, so split them in half. Alright, so those are our quick properties we're going to be using here. So let's go ahead and look at this first one. Oh, apparently I didn't erase everything. Here we go. So, AD. Well, let's look at the side opposite of AD. That's BC. Opposite sides are congruent. So if we know that BC is 8, AD has to also be 8. Alright, DC. Again, I don't know the length of DC. However, if I look opposite, I see I have a side opposite that's 15. So therefore, DC has to be 15. So let me label this here. I always like to mark up my diagram every time I discover something new, so I can keep track of it. So angle A, well, let's look. If I knew angle C, I would know I would be able to find the measure of angle A. It'd be the same, but I don't know angle C. So now, let's look at the consecutive angle D. Consecutive angles are supplementary, so that means that the measure of angle A plus the measure of angle D has to equal 180. So what we want to do is 180 minus 68, and that's going to give us the measure of angle A. Calculate that for me really quickly. Okay, 112. From here, it's easy, smooth sailing. Easy sailing, that's not a phrase. Okay, so angle B, here's angle B. Well, what's opposite of angle B? Angle D. Do we know that measure? Yes, we do. So because angle D is 68, angle B has to also be 68. Opposite angles are congruent. Angle C, we could use a lot of different things to find angle C. I think using opposite angles are congruent is the easiest. So if we want to find angle C, let's look at the angle opposite of that, which is A, and that's 112. So therefore, angle C has to also be 112. Alright, so that is number 1. Here's the deal. Number 2 is a lot like number 1, so I'm actually going to have you try this one. So you can pause the video and then try number 2. I will put the answers up later. Alright, let's look at number 3. Now we're going to be looking at diagonals here. So UT is right here. If I know the opposite side from UT, then I can find the measure of UT. So opposite of UT is RS, which is 27. Opposite sides are congruent, so UT is also 27. Same thing here. ST, well, what's opposite of ST? RU. Is that, do we know the measure of that side? Yes, we do. So we can say that ST is 18 degrees. Now let's find VS. So here's VS. that's a part of a diagonal. So let's look back. Diagonals bisect each other. So that means that this whole diagonal can be split into two. If I know half of it is 7, that means the other half has to also be 7. So VS is 7. Now to find VT right here, we think, well, I don't have enough information, but we do, and I want you to look down here. You see an asterisk with some other information. You'll see that a little bit throughout this packet, so just pay close attention there. So RT, so this whole diagonal is 30. So if we split it in half, that would mean that each half is 15, okay? So VT is 15. So there's number 3. Let's look at number 4. All right, so remember when we're naming angles, the angle we're talking about is in the middle. So the other letters are like kind of like your starting point and your ending point. So we're going to actually outline the angle, and that's going to help you. So just point out that this, we are given another piece of information. I'll outline that for you, and then I'll have to erase it. So F, E, D. Do you see how I outlined the angle? So we're talking about this whole angle right here is 134 degrees. So if we want to find D, E, C, I'll outline that in a different color. D, E, C, we're going to need to use this information. So we only want to find this portion, and we know the other half of that angle is 71. So what we want to do here is 134 minus 71, and that's going to give us what's left over. So 134 minus 71 is 63. So that means that we can label this as 63 degrees. Did I put? Yeah, I did. Okay. So now let's look at CDE. So let's outline it. C, D, E. So now we're talking about this entire angle here. So to do that, we actually need to know this angle, because we know opposite angles are congruent. So where should I write those? So what we want to do is focus on this angle first. I know that consecutive angles are supplementary, so that means that this angle plus this angle has to add up to 180. So what we want to do is 180 minus all of this angle E, which is 134. So let's calculate that. What is that? 180 minus 134. So that equals 46. So that means that this whole angle here that I am like trying to point out, this angle right here, has to be 46. So that means that the angle opposite of it also has to be 46. So CDE is 46 degrees. Let's just take this a step further because we can. If I know that this has to be 46 and I know that part of it's 21, what does this part have to be right here? How would I find that? Yeah, I would do 46 minus 21, and you're going to get 25 when you do that. Okay. That was a lot. Okay, so ECD. ECD. So I'm looking here. ECD. So this is where it gets a little bit tricky. I really want to point out that opposite sides are parallel. So I'm going to extend my drawing here. Stay with me. If I extend CD, it's going to look like this. Hopefully this helps you visually. Okay. I'm going to extend FE. And then I'm going to make CE be a transversal. Do we see that we have a set of parallel lines cut by a transversal? Now, I want you to look at the angle we're trying to find the measure of, which is ECD right here. It's inside the parallel lines on the right of the transversal. I want you to look down here at this angle. This angle is inside the parallel lines to the left of the transversal. What do we know about this angle and this angle? What do we call them? Okay, we call them alternate interior angles. So I'm going to write a note here. What do we know about alternate interior angles? Well, they're the same. They're congruent. So that means that ECD has to equal 71 degrees. So I can label that here. I know that got a little tricky there. All right, let's look at DFE. So DFE. See how I am literally highlighting that angle there? Oh, we already found this. We found this earlier. Remember that we did 46 minus 21. So that is 25 degrees. Now, I want to make a note, though. You don't have to go in order. It actually might have been easier to go out of order here. So know that you have that option as well. All right, so that's number 4. We're going to do one more of these together, and then we're going to do the second page in a different video. So I'm going to have you, after we do 6 together, you're going to try this. So you try. So let's go ahead and look at number 6 together then. So it says find the measure of angle B. So this is our goal is to find this measure. But in order to do that, we need to figure out some more angles. So what I want you to look at is the angles that we have. We have angle C and angle A. What do we know about opposite angles? They're congruent. So that means angle A is congruent to angle C. So that means that 6, we're going to set up an equation here, 6x minus 15 has to equal 4x plus 11. Can we solve this equation for x? Yes, we can. Let's bring that 4x over by subtracting it on both sides. So that makes 2x minus 15 equals 11. Now let's bring that minus 15 over by adding it to both sides. And then I have 2x equals 11 plus 15 is 26. Divide that by 2. And I have x equals 13. So x is 13, which is good to know, but it doesn't give us an angle. So now we want to use the x is 13 to find the measure of angle A. You could use it to find the measure of angle C. I don't know why I chose A. I think I just wanted to, but you could have done this with angle C as well. So what we're going to do is find the measure of angle A by plugging in 13 for x. So that is 6 times 13 minus 15. So calculate that for me. All right, you should have gotten 63. So I'm going to label this 63 degrees. So now we found x, check. Now I need to find the measure of angle B. Now, remember, consecutive angles are supplementary, so they add up to 180. So that means that 180 minus 63 is going to equal the measure of angle B. What should that be? Calculate it for me. 117. So, final answer, measure of angle B equals 117. Alright, so that's number 6. And number 5, all you're being asked to do is find x. So you'll only have to do like this portion. Think about how opposite sides are congruent. Okay, so I'm going to stop there, and I'm going to make a new video for the second page.